Okay, nice job on that module. Let's talk about one more topic that we'll need before class when we do something a little more interesting with audio. And this is arrays in Java. So I'll make another program, another source code file here. I'll call it simplearray.cpp. So I kind of alluded to arrays in the last module by talking about the command line arguments. Let's dig into that a little more. So we'll include the same stuff. So I'll say include stdio.h, that's standard input out. Include stdlib.h, just in case I end up using something there. So this is the standard library, it comes with a bunch of little things. Okay. So just as before, I'm going to make my int main. Not going to worry about command line arguments this time. I'll just keep it blank. And I'll return 0 saying everything's A-OK. All right. So let's declare an array. Now the syntax here is a little bit different. Let's see what happens if I try to do this like I did in Java. If I say int array equals 1, 2, 3, what's going to happen when I go to compile this? So I'll say g++ simple array. I use the tab there to autocomplete, by the way. That's very useful in the command line. I'll output this to an executable file called simple array. And when I do that, it says expected initialize before array. So it gets confused. Turns out, for arrays in C++, this actually needs to be after the name of the variable. Okay. Now it's fine. Okay, so that's one little difference there that's a bit annoying and may take some getting used to. So remember, if you get this error, unexpected initializer before your array, probably means that you have to use this syntax and move those two brackets to the end of the variable name. Okay, but fine. Now let's just show you. If I say printf, and I'm just going to print a number and then followed by a line break. So if I go to print some integer, and I'll make that integer the array at index 0, take a moment, pause, and see if you can guess what that will be. So actually, I want to run simple array, and it prints out 1, right? Because these arrays are 0 indexed, and 1 is the first element in the array. Okay. Let me mix these numbers up a little bit. I'll say 8, 10, 4, 3, 4. Okay, now you see it's 8 is an index 0. Okay, so the first difference we had was just that we had to specify the syntax. But there's another major difference. These arrays do not come with lengths. We cannot say something like for int I equals 0, I is less than array.length I plus plus. Let's see what happens if we try to do that. So yeah, if I was going to try to print out the elements here, so I'll make I my variable that I'm iterating through, and I'll pull it out of the array at that index and print it. If I try to do this, it's not going to work out so well. What is it going to say? It just says request from member length in an array, which doesn't exist. Okay. So here's one thing you have to do manually in C++ that you didn't have to do in Java. You actually have to know how many elements are in the array. And I know right now you're probably screaming, oh my goodness, magic number. Okay, but let's just do it for a second just to get it to run. All right, so this printed it out. Now, so usually what you end up doing is declaring another variable that holds the size. So you really need two variables for your array most of the time. So the array itself, but also a variable holding its length. So okay, so I got rid of the magic number if I know that n is referring to the length of the array. Now the code works just the same. Okay, but what if I get this wrong? What if I thought that the length was 6? Okay, let's see what happens. In Java, this would give us an out of bounds error, right? As soon as we went past the end of the array, it would throw an exception. What is this though? That number is nowhere. And maybe let's go even further and see what happens. Okay, so it's just like pulling out random stuff. All right, so here's the deal. An array is really a reference to an area in memory. Just like you had those object references, an array is a reference to a block of numbers in memory. And there, you know, it's just a little chunk of memory, but your memory is huge and there are things right next to it. So those things are random and it depends on what programs ran before you ran this. And it'll just print what those are out. So how far can we go? What if I try to go up to 100? We're just gonna get a bunch of random numbers. Yeah, it looks like we are. Okay. Let's keep going. Oh, it's still going. Okay. Sometimes it'll crash if you do this. Actually, I think I know what's happening. Okay. I'll get to show you a crash with the next thing. All right, so this is an example of an array that you initialize that's fixed, right? But what if you want to dynamically allocate an array? So that's the nomenclature we use, dynamically allocate. So in other words, you don't know what's going to go in the array or even how big it is until runtime. Okay, so we could make this a command line argument, but for now I'm just going to make it n, and I'll make that the length of my array. Well, this you do the exact same way you would in Java. So you could say array is equal to new int n. Okay, so that's fine. Let's just go ahead and print what's in it when we do that. It says initializer fails to determine size of array. Okay, sorry, we have to switch one thing. I forgot. Okay, sorry. Okay, now we're good. All right, so it turns out, let me keep the syntax that was there before just for your reference. But to do a dynamic array, it's actually a completely different syntax. I actually always use this syntax. I was trying to keep something similar to what you would see in Java, but I forgot that, yeah, I always use this syntax, so I didn't remember that it's the only thing you can do for this. Okay. So you just have to remember, so this int star, this will make a little more sense in the next few days what that actually means. For now, this is what you need if you're going to have a dynamically allocated array. Okay, so if the size is not known until runtime, you need to declare it as int star array. Okay, so the square brackets aren't going to work there. All right, so let's see. Okay, now it turned out everything was 0. I don't think that's guaranteed, but maybe this compiler is doing that. Okay, so this pulled out a whole new thing. In memory, it pulled out 100 zeros, and it made my array. Now, of course, I can put things in there. So I can say array at index I. Let's maybe make it, we'll say pow. We'll say 2 to the ith power. Actually, we're going to get overflow here with 100. Let's just go up to 10. Okay, so PAL should be part of the standard library. No, it's not. What is that actually? Is it PAL2? EXP. Nope, we need to include math.h. Now it should work. Okay. There we go. All we needed was math.h. Okay. So if I run this, it's actually filling in the array with powers of 2, and it'll just print them out just to show us. Okay, and there they are. So we just filled an array with powers of 2. Whoop-de-doo. Okay. But here's where it gets a little interesting. Let's say I go beyond the bounds of the array. Just like I did before. Am I going to pull out random numbers? Well, interesting. It let me keep going, but let's actually go even further. So this array is only supposed to have n elements in it, but somehow I'm filling in elements elsewhere in memory where I really shouldn't be. This is where I say this is one of the safeguards that's not there, that you have to be really careful with. Let's go up to like 20,000. So this is only 10 long, so we're going to go way past the end of it. Oh, wow, this thing is more robust than I thought. I'm having a hard time getting it to crash. But this could be very bad. Okay, let's see. Let me make this a little bigger. There we go. Finally got it to crash. Excuse me. So, okay, just to show you, it doesn't normally crash. If I go up to the correct bound, it's fine. But let's say I try to go 2 past it. Okay, I'm okay if I go 2 past it, but I'm really not supposed to be, right? Let's go double past the end here. Okay, I'm okay double past the end. Let's go a factor of 20 past the end. Okay, then I get a segmentation fault. This is your worst enemy with C++. Segmentation fault. What it means is you've accessed a region of memory that you were never supposed to have access to. Okay. So I'm really only supposed to be touching n integers in memory here. I've gone way past that. And I'm trying to assign to indices that I never should be able to. Okay. So I have to be careful of that. So that's one safeguard you don't have. You don't get an out of bounds error, so you can try to change things in memory, but sometimes the program will just crash because you're messing with memory that you should not be, and it totally messes up the program. Okay, so that's one thing. Just one more thing, though, you need to be aware of. When you do this dynamic allocation, you have to actually remember to clean it up before the program ends. So not only do you have to remember the length, but you have to remember to delete it before the program is done, or before you finish using it. It doesn't have to be at the end of the program, but when you're done and you want to make space for other dynamic things to occur, you need to get rid of it. So the command there is delete R. Very important. Clean it up, all right? Just like I'm going to ask you to do in class on Friday. I need you to clean up after yourself, okay? So you made this dynamic array at runtime. You pulled out some memory. Every time you see a new, there should be a delete somewhere, okay? So just to show you, this program runs fine, and it ran fine before, but it won't run fine if this sort of thing is in a loop, and you keep doing this and you don't delete it, because then you get something called a memory leak. If you don't clean up after yourself, it doesn't know, C++ doesn't know that it can reuse the memory. So it's going to keep filling and filling and filling until it's past full. You got to tell it, hey, I'm done with this memory. You can use it. You're good to go. So this is the first time we're seeing this with dynamic memory. That's what it's called. So we say we dynamically allocate the array, which means we have to clean it up. Okay, but otherwise the syntax is very similar to Java. So I'm going to have you do an exercise real quick where you write a method that reverses an array. So what it'll do is the return type will actually be a dynamic array. So I'll say int reverse array, and we're going to pass in an array. And so what you're going to need to do is to make a new array. So dynamically allocate. So dynamically allocate new array. And then you're going to fill this array with the elements in reverse. Now, of course, there's one more bit of information I need you to know. I'm going to have to pass along the length of the array to this method as well. Otherwise, I would have no idea how long to loop or how big to make this reversed array. Okay, so do that exercise and we'll be finished, this module. And tomorrow in class, we will look at some examples with audio, which is just a big old array. We're going to get you some experience with C++. Okay, enjoy, and I'll see you tomorrow.